Scientists have made an important discovery which they say calls for a rethink about how stars evolve. They've found the majority of red giant stars, or dying stars, have strong magnetic fields 10 million times stronger than the Earth's, and the findings are published in the journal Nature. So what does that mean when it comes to our understanding of the universe? Joining me now is Associate Professor Stello, the lead researcher and astrophysicist at the University of Sydney. Can you tell me firstly what's so special about this discovery?
So the discovery is really a complete surprise to us in terms of the result that we get, because in the past we only thought that roughly 5% of stars had strong magnetic fields. And with this result we now know that up to 60% show strong magnetic fields. And so we have to move our understanding of stars from something where we can ignore magnetic fields because they're rare to something where we really have to include it in our models in order to, in a more proper way, understand how stars evolve.
So in terms of our audience understanding it, you've brought a couple of bottles in. Now, can you tell me how that relates to measuring this in stars?
Yeah, so we use a technique called astroseismology. It's essentially using what geophysicists use in order to understand what's happening in the Earth. They use earthquakes. And we use starquakes because they make the whole star ring. And so I can make my bottle ring by blowing on top of it like this. So it produces a sound. That sound tells us something about the physical properties. I can show the difference with another bottle here. It produces a different sound. And it's largely because this bottle is much bigger than this one. But also if I change the physical properties like the gas inside, the temperature, that will change the frequencies that are produced, and also in stars. And so we figured out by measuring the frequencies of the sound waves in the stars, which are revealed by small variations in the brightness that come from them, which we actually measure, we see that some stars are missing certain notes. There's certain notes they are not playing, and it's because there's a very strong field in the core that is dampening those notes.
So you're sort of measuring the music of the stars?
That's exactly what we're doing.
So can you tell me what process is involved in actually doing that? Where do you get the data from? Where do you even begin on a massive project like that?
Yeah, so we were quite lucky to get data from NASA's mission called Kepler, which has just finished, and we are now in the process to actually digging through all the data. And so we have now tens of thousands of stars that have been observed for 4 years continuously by Kepler, and it measures the brightness of stars extremely accurately, and that accuracy enables us to see the variation caused by the ringing, and therefore we can get the frequencies of that ringing.
And this is important, isn't it, when it comes to understanding how old a star is?
Exactly, because if you have a very strong magnetic field in the core, that's where the engine of the star is, all the burning of hydrogens or helium, that will actually change the processes and therefore how quickly it grows old. And so we need to include that in our models now to see how that changes the ages of stars.
So can you tell me what this means for Earth, in particular when it comes to our understanding of things like clouds and communication systems?
Yeah, so we know the magnetic field in the sun has an effect on its surrounding, including the Earth. So every time the sun is very magnetic active, it can spew out charged particles that can hit Earth, and that can interact with cloud cover, it can interact with our communication systems. And so understanding magnetic fields in stars more generally, which our research can do, we hope to get a better understanding also about the magnetic fields that are in our sun.
Clearly you've been working in this field for a long time. Is it fair to say that this discovery is a game changer?
Well, every article in Nature is hopefully a game changer. Sometimes it turns out not to be. We feel, though, that we are on pretty safe grounds, and we have already worked on follow-up papers on our program, and it seems to support what we have found so far.
So will this boost our understanding of the origins of the solar system?
I wouldn't put it that far, but it would in the long term hopefully give us a much better understanding of the magnetic fields that have been part of forming the solar system and other solar systems out in the universe.
Stello, thank you so much for that today.
Thank you.